Okay, now we are going to build the exclusive OR gate, and which now the symbol for this gate looks something like this. Now now we'll go on to build the okay. First I'll show you the truth table for this gate. Then we'll build this gate with the combination of all the gates we have built so far. We have two inputs, A and B. We have output, which is Y, A, B, and Y, which is A exclusive or B. This is the sign for the exclusive OR. Now we have our combinations of inputs as usual. Now what exclusive OR gate does, it will give you 0 if both the inputs are same. It will give you 1 at the output if the inputs are not similar. So for 0 0 they are same, you get 0. For 1 1 they are same, you get 0. But for 0 1 you get 1. For 1 0 you get 1. Okay, so this is the truth table. Now we will build the exclusive OR gate with the combination of some gates we have built so far. Then I'll also build this truth table again with and trying to show you how it works, how we build it with the other gates. Okay, so we have our two inputs, which is A and B, and we can give it to OR gate. They are odd. Then I'll check these two again here. I'll give this to input to the gate here. Then I'll end this. I'll put on an AND gate in front of these two input, and that will give us Y, which is A exclusive or B. Okay, yes, that should give us this. Now we will build our truth table again with these, considering this way. We have in A, we have B, these are two inputs. Then we have A plus B, which is OR this input, A plus B. We have A multiplied by B inverse, which is our NAND gate, and they are ended here, which is Y equals to A B, or simply these two in multiplication, which can be represented here this way, as far as I know, which is A B bar plus A bar B. So multiplication. So for yes, that gives us or yes, this equation turn out to be this. We can write it here, which is our exclusive OR of A plus B, right? This is the logical math, sort of. Okay, now we're gonna build. We're gonna see how it works. We would have our inputs again. Now we'll need, now here it is OR of A and B, which is this. We have seen it already. Now we have NAND of A and B, which is this. Now we have AND of these two. So 0 and 1 being ANDed, go through AND gate, it's 0. 1 goes to AND gate, it's 1. 1 goes to AND gate, it's 1. And 1 0 goes to AND gate, it's 0. So here we get our desired truth table. So this is the exclusive OR gate, very useful. Now I'll build another gate which is just the inverse of exclusive OR gate, which is exclusive NOR gate, and its symbols and symbol is just like, it's like this. Simply, if you know, it is simple if you know the exclusive OR gate already. It differs with, this symbol differs with exclusive OR by just this circle. And okay, so you can build this simply by adding a NOT gate at the output of the exclusive OR gate. So you'll get this now, and this is okay. This is the truth table for exclusive NOR gate. We got 0 0, we got 0 1, we got 1 0, and we got 1 1. So we would have 0, we would have 1, we have 1, and it's a 0. And we inverse this, we got 1, we got 0, we got 0, and we got 1. So this is our exclusive NOR gate. Simple. Okay, we are done with this. Now I have talked to you. There's one important gate being left, which is the buffer gate. So okay, let me show you the buffer gate. Here, let me show you the buffer gate. Buffer is simple gate, one terminal input, one terminal output. Here is the truth table of buffer. So here's A, this is Y, so this is A, this is Y. Oh, sorry. This is A, this is Y. Here's our truth table. You give it 0, it will give you 0. You give it 1, it will give you 1. Simple. It's the buffer gate, and the symbol is like this, just like NOT gate, but without the dot. NOT gate looks like this, but with the dot here. Now you might ask, what is the purpose of this gate? What's the use of this gate? So as I have told you in the start of the video, that whatever we have built here on the breadboard are not best by their configuration. We're just trying to make the logic, not the right configuration. That's the part of electrical engineering. So the buffer is simply a circuit where you wanna change the impedance values to match the impedance value from one gate to one gate. So you just simply put on the input here and you get the same output, but the impedance here and the impedance here are different. So that's why the buffer is also important. You may never get to see if you're building the logics, but when they print the chips, the processors and all the logic chips, the digital electronics chips, they use buffer a lot to match the impedance stuffs. And it's simple the way is simply built on the breadboard by using a single transistor. So that's it for this video, guys. Hope you learned something. This is my first video, so if I have missed, and I think I have mistaken a lot, so please pardon me for that, and hopefully I'll see you in the next video. Thank you and bye.